Plastics are commonly used in everyday life because they are lightweight, durable, flexible, strong, and have low cost production. However, plastics have a major negative impact on the environment due to factors such as their waste production and dependence on oil. The good news is that biodegradable plastics can be used to reduce the environmental impact of plastics. But how does that work? Well, understanding a little more about the organic chemistry unit can help. So first, what even are biodegradable plastics? Well, they are a kind of plastic that can be broken down over time by certain microorganisms into simpler substances such as carbon dioxide and even water. These plastics are vital to the solution of plastic pollution because they have the potential to reduce the long-term environmental impacts of plastic waste by recycling it over and over, helping to prevent the persistent microplastics from accumulating. That's why it's key to enable proper disposal of plastics so we can create the perfect conditions for effective biodegradation. With a good understanding of the organic chemistry unit curriculum, we can gain valuable knowledge into the composition and behaviors of biodegradable plastics.
Okay folks, time to apply this knowledge. Now, in the organic chemistry unit, we learned about the structure and properties of carbon-central compounds, which, by the way, are the building blocks of biodegradable plastics. The various functional groups, polymers, and reactions involved in organic synthesis that we've spoken about so far are all crucial in helping us to understand biodegradable plastics compositions and chemical processes that occur during their degradation. Monomers being polymerized to form long chains is really significant for the creation of biodegradable polymers, so learning more about these in the organic chemistry unit were important as we gain knowledge of how polymerization reactions involve the bonding of monomers, which are smaller molecular units, through the chemical bonds to form a larger polymer structure. With regards to biodegradable plastics, the types of monomers and bonds formed during polymerization play a role in influencing the plastic's stability and biodegradability. For example, bioplastics often have monomers that derive from renewable resources like starch or polylactic acid, so those monomers can undergo polymerization to form chains that exhibit biodegradable properties that can be easier to reform and recycle. Even the chemical bonds and overall polarity formed during polymerization also affects its stability and biodegradability of the polymer, just like how ester bonds in PLA polymerization contribute to its durable biodegradability. Microorganisms can easily recognize and break down the ester bonds through enzymatic processes, leading to the degradation of the polymer into simpler pieces that can be recycled. That's why understanding polymerization reactions and the different types of bonds involved allows scientists to create more biodegradable polymers with desired properties. Keep in mind, this content is also directly applicable to realizing how bacteria and fungi decompose biodegradable plastics in the natural environment or composting facilities. By selecting more appropriate monomers and controlling the polymerization process, it's possible to create materials that exhibit both desirable mechanical properties and the ability to biodegrade when exposed to the right environmental conditions, facilitating its decomposition when it reaches the end of its life cycle. Even those pesky functional groups are essential in understanding biodegradation and bioplastics, as these groups, with their specific arrangements of atoms within a molecule creating their own unique characteristics, can determine the plastic's chemical reactivity and properties. The presence of ester groups in biodegradable polymers like polylactic acid can help to prove this, as this group can aid in the enabling of enzymatic hydrolysis, facilitating the breakdown of the material into simpler compounds during biodegradation. By analyzing the functional groups in plastics, researchers can assess their susceptibility to biodegradation, design materials with desired properties, and develop strategies to enhance their environmental sustainability.
So, in conclusion, paying attention to the organic chemistry unit can be very important for comprehending how biodegradable plastics actually work. Topics we've spoken about in this unit, such as polymerization reactions, the role of functional groups, and the structure-property relationship of organic compounds, can provide valuable knowledge into the composition, stability, and biodegradability of these materials we deal with in daily life. By connecting our knowledge of organic chemistry to biodegradable plastics, we can gain a deeper understanding of how to develop sustainable solutions to plastic waste and make better choices with regards to their use and disposal. Let's appreciate the design and development of biodegradable plastics, evaluate their environmental impact, and continue to search for sustainable solutions to plastic pollution.
Whoa, before you guys go, we do need your opinion on something. Now, biodegradable plastics are known to be better for the environment compared to regular plastics. However, they can still have a negative impact on the environment. So, after doing a bit of research, let us know if you think that heavily relying on biodegradable plastics still diverts us from the urgent need of alterations to our waste management practices in order to find real solutions to plastic pollution. Should we aim to switch over to using only biodegradable plastics, or should we aim to stop using plastics entirely? Leave your ideal plan thoughts in the comments section below, and that's it from us. We hope that you learned something new today about biodegradable plastics in the environment and how the organic chemistry unit can help play a role in our understanding of it. Thanks for watching, and we're out. Peace.